Welcome everyone. I am Swati from Sri Venkateshwara College of Engineering, second year, third sem. Now I am here to explain about the concept of interrupts in the digital design and computer organization. Now let us start the session. The topics to be covered in this session are Introduction to Interrupts, Types of Interrupts, Interrupt Handling Process, Interrupt Vector Table, Interrupt Prioritization, Interrupt Latency, Interrupt Masking, Interrupt Driven Input Output, Interrupt Handling Overhead, Conclusion. Now let us start the session, that is Introduction to Interrupts. Interrupts are an essential concept in digital design and computer organization. An interrupt is a signal that causes the CPU to temporarily suspend its current execution and handle a specific event or task. Interrupts help in managing multiple processes and handling time sensitive events effectively. Next is types of interrupts. Hardware interrupts, software interrupts, and exceptions. Hardware interrupts generated externally by devices such as keywords, timers, or input output devices to request attention from the CPU. Software interrupts generated internally by the program or operating system to initialize a specific function or service. Exceptions generated when the CPU encounters an error condition of an unusual situation. Next is interrupt handling process. When an interrupt occurs, the CPU saves the current state, including the program counter and registers, to resume execution later. The interrupt handler, also called an interrupt service routine, that is ISR, is the invoked to handle the interrupts. After handling the interrupt, the CPU restores the saved state and resumes the interrupted program. Next is interrupt vector table. An interrupt vector table is a data structure that holds the address of interrupt handlers for different interrupt types. Each interrupt type has a unique number or code associated with it, known as the interrupt vector. The CPU uses the interrupt vector to locate the appropriate interrupt handler in the interrupt vector table. Next is interrupt prioritization. Interrupts can have different priorities to ensure that critical events are handled first. Priority levels are assigned to interrupt with higher priority interrupts taking precedence over lower priority ones. Interrupt prioritization is crucial for real time systems to ensure timely responses to time sensitive events. Next is interrupt latency. Interrupt latency refers to the time it takes for the CPU to respond to an interrupt. It includes the time taken to save the current state, locate the interrupt handler, execute handler, and restore the saved state. Minimizing interrupt latency is important in time circuit application to ensure prompt handling of events. Next is interrupt masking. Interrupt masking is the process of temporarily disabling interrupts to prevent their immediately execution. It is useful when handling critical sections of code or when certain conditions need to be met before an interrupt can be processed. After the critical section is completed or the conditions are met, interrupts are unmasked to resume their normal operation. Next is interrupt driven input output. Interrupts play a crucial role in handling interrupt input and output operations in a computer system. Instead of continuously polling for data, the CPU can be interrupted when data is available for processing. This approach offloads the CPU from content constantly checking for input and allows it to perform tasks until an interrupt occurs. Next is interrupt handler overload. Interrupt handling introduces overhead due to the additional operation required to save and restore the CPU state. The interrupt handler itself also adds overhead as it needs to execute before the interrupted program can resume. Optimizing interrupt handling is important to minimize the impact on overall system performance. Now we reached the last part of the conclusion session, that is conclusion. Interrupts are a fundamental aspect of digital design and computer organization. They enable efficient handling of events, prioritize critical tasks, and facilitate interrupt driven input output. Understanding interrupt mechanisms and optimizing their usage is crucial for designing higher performance computer system. Now, thank you for everyone watching my video.